Okay, so thanks for joining, everyone. And yeah, for me right now it's quite late. It's actually midnight, based in Lithuania, Europe. But anyway, I'm not sleepy, right? Because I'm a developer and I never sleep. I just go to standby sometimes, right? So yeah, so it's fine for me. And thanks for this invite. And yeah, I'm happy to talk about our experience of the way how we use gRPC. And just a very quick introduction of what we do. We startup, machine learning related startup, and we implement different solutions that help to automate enterprise. And one of the things, for example, we work right now is automatic extraction from data extraction from the documents and automatically processing invoices and stuff like that. And my background is software development, so I jumped into machine learning from software development, and from the start what I saw is, like, when you start with machine learning, you usually start with notebooks, CSV files, and you load CSV file into the notebook, process data, train model, and then you run inference. But this is fine when you do study, when you study machine learning, but when you actually want to move your model to production, it's completely different story. Because you when model runs in production and when some problem comes and you need to fix the code, if you have this spaghetti code and everything is inside, all the code is in a single place, then becomes very hard to manage the stuff, especially because in machine learning you have to put quite a lot of logic for data processing, to clean data, process it in a certain way, and so on. And if you do processing and model training and inference in a single place, it works up to some point when complexity grows, and it's hard to manage the stuff. Yeah, and by the way, if you have any questions in the meantime, just yeah, you can stop me and ask, so I'll be happy to follow up. Yeah, so what we saw is that it doesn't work when to run everything in one like monolithic application with machine learning. But what typically you would see when you would start with ML, when everything runs in a single place. And then we decided that for our product we need to split. We need to have separate services. Each service would be responsible for its own stuff. Like data fetching, data transformation, data cleaning, data processing. Maybe it will be done by service A, and then once data is ready, we could transfer this data to another service which would do model training, and based on that data, and when model is ready, then there'll be another model which should serve API and would allow to execute like inference requests to do the processing. Right, and then the question comes with that. Okay, we can split, but this one specific about ML is that you operate with usually with large sets of data. So when you train the model, you need to have training set, validation set, testing set, and usually there's quite a lot of data, and you need somehow to transfer this data from one service to another, right? And the first option that would come to the mind would be to use JSON and REST calls over HTTP. It works, but it's not convenient because as data sets are quite large, then you may have lots of attributes as well in the data sets, and then if you use JSON to send data over between services, then it comes extra complexity when you need to parse the data, when you get this JSON text, and then you need to parse all the data, and especially the problem is with numerical data. You may lose some precisions, and so on and so on. So there are lots of small details that kind of hidden, but then as you start to work with that, it comes to the surface, and it becomes quite complicated. So then we started to look for alternatives, what other options we could use to implement communication between services, and we find out that gRPC is quite suitable for our case, because, and I'll show later that in a demo, because with gRPC you can quite easily transfer data from one service to another, and you don't need to play with data parsing, because you kind of you're able to define a method which returns a type, and this type could encapsulate different multiple data sets. So in a single call, you could return, for example, training data set, validation, and test data set, all the data that you need, and run the logic. Okay, so this was introduction, and now let's jump to demo application. And before that, I'll just a few words about the model that I'm using for this demo application. So the model is based on this article that I wrote back in December on towards data science, and this model is the idea of the model is to keep it simple, right? And it's using standard data set that you would be able to find in different ML examples. This is Boston housing dataset. It comes with a set of attributes that describe price for certain like real estate, like house, for example. And to make this model slightly more interesting, we are training a model to kind of forecast not only single attribute price, but also additional attribute pupil-teacher ratio, so that based on a set of attributes, model is able to predict price for this house based on the neighborhood, maybe when the house was constructed, and so on and so on. And additionally, it's able to predict another attribute called PTR. Just to make it more fun. And yeah, if you would be interested after the webinar to read more about this sample model, you would go for that article. And also all the source code is being provided on the GitHub, and is being referenced in the bottom of that article. Okay, so let's jump to the source code. And I have demo application is quite simple, because I thought it should not be overcomplicated in order to for you to understand what we are doing here. So it's not this demo application is not our main product, but I implemented separate application, obviously, which specifically shows the main solution which we are using, and it highlights the advantage of gRPC for ML domain. Okay, so first there are two applications. The first one is implements data service, and second one implements training service. So the idea of data service is that it should read data, load it, clean it up, remove some attributes that we're using as a target attributes, right, and then split data into training and test sets, and then do data normalization as well, because in ML, when you have data set with certain numbers, it doesn't work to send this raw array for training, because if number distribution is quite high, you may have one attribute can be like if the scale is different, so one attribute is like maybe from 1 to 10, another attribute from 1 to 10,000, and in this case, model would not train very effectively. So you need to do data normalization, and you need to translate all the attributes to be in the same scale, for example, from -1 to 1, and this is kind of common task in ML. So this job is done as well as in data service. Then all the data is being prepared and is being sent to the caller. And the caller in our case would be a training service, which is another application which using gRPC to make a call to a data service. It gets the data, and based on that data runs the training. So essentially, this is very common ML flow, but the main difference, if you would look for most of the examples of ML tutorials or just any like overview material for ML, you would see that these two steps are done usually in the same application. So the idea here is to split and have two different applications to do this to do the job. And okay, if you look into the data service application, we have defined here data service proto file, and in this proto file we define messages for the request and response. Request is quite simple, just one attribute, test size, and it's kind of with this parameter we can have the option to split original data set into the training set and test set based on the percentage that we specify in this test size parameter. For the response, we return multiple attributes. We return normalized data for train test sets and then validation set normalized as well, and we additionally return target attributes. So for train test and validation, so the target attributes would be used by ML model to when training will run, and it will try to match input attributes from train test validation sets with those target attributes from train test and validation, and will try to build patterns or rules, and then later it will follow those patterns to work with unseen data. Okay, and to make it to keep it simple, there is one service defined Boston housing, and this method called prepare data is being defined, which accepts parameter to set the testing size, and it returns the response, all the data that was prepared, right? And then the next step, what we do when we have this proto file, we generate client, gRPC client and server. And for those of you who would be interested how we do it, I included a README file over here. Yeah, and by the way, this source code that for that demo that I'm showing is also available on GitHub, and you could find it. This example is available for anyone. So you could try it out and play it after the webinar as well. Yeah, so what I like with gRPC, because in the past I was working a lot with SOAP web services, and you know, in SOAP, when you want to generate a client for the web service, you have the option to generate. I was working with Java, right? So there was option to generate proxy code, which helps you to make a call to the SOAP service. And always this code that was generated was very cumbersome, and in case of SOAP, many classes were generated, and it was hard to manage all the stuff. And what I love in gRPC is when we generate code on top of this proto file, there are just two files being generated, and they're quite simple. And this is what I like, because you don't overcomplicate your application. It's kind of easy to manage. You get those two files, and then you use the same files on a server and on a client. The same scripts are being used to make a call, right? And this is convenient as well, because you could reuse the same stuff on a client and on a server. Okay, and then Then we have data service class is responsible to serve API in this case, and this is kind of in this demo. This is a standard code that you would see in gRPC documentation. Nothing special over here. And what we do here is we call start method from the server, and we start listening for incoming connections. And this is where this class, it implements Boston Housing Servicer, the one that was defined in Protofile, and we import the script which was auto-generated from the Protofile, and over here we implement prepare data method, the method which was defined over here in metadata file, right? And this is the main logic where we handle stuff. So we call the first thing we call prepare datasets method from data helper, right? And if you look into the data helper, this is standard code that you would see in most of the ML examples, right? Prepare data sets. So we do here, we load data, then we create pandas data frame, then we extract target attributes, we split data into train, test, validation, then we create target attributes, then we normalize data for train, test, and validation sets, and then finally we return all those sets back to the caller, right? So the data is being prepared, and in this case, as I mentioned already, standard ML code is being used. The same code you would see anywhere in any ML implementations typically. Right, then we get back datasets, and then we here print out information about datasets just for debug purpose, and then at the end we would construct a response of the same type as it was defined in Protofile, Boston Housing response. Then we for each element from that response we assign the value. And the tricky part is that we operate with NumPy arrays. When we prepare datasets, it's not just a simple Python array or whatever. It's a NumPy array, and by default, gRPC doesn't support NumPy type, and you cannot just out of the box simply send this array through gRPC. But the standard way how to solve this problem is to create byte array, because NumPy library allows to convert or save NumPy array into the byte array using standard save method, like we do it here. So we create bytes IO object, and then assign we basically copy from original NumPy array, we copy this array into the bytes array, and using a NumPy save method. Right, and the same stuff is done for all datasets, and then this datasets that from NumPy array basically are converted to bytes array are being sent for the response. Okay, so now if I could start this service. It's up and running, and then if I would go to training service over here, we have the same both gRPC files that were generated in data service. The same files are being copied over here, and then we have, just for demonstration purpose, training service test script is being created, which initiates training service. This is the one, and then we call run training method, right? And this is the main method, which is here. And what we do here, we first of all we fetch data, right? And we call fetch data method, and this method gets the data from data controller from here. So we got our fetch data method, which actually what we do here, we use gRPC API and we pass input parameter test size, which will be used to split data into training and test sets. And we make a call, we call prepare data method, and we get back response. And response returns byte arrays. And then we need to load, because we want to keep operating with NumPy arrays. When we run training, we want to use NumPy arrays, so we need to load back from bytes array into NumPy. And again, we're using here standard NumPy method called npload. So no hacking, nothing special, just using standard API. Right, and the only tricky thing here is that when target attributes array was converted to bytes array, it was target since we use our model is training for multiple attributes, for 2 attributes to be precise, and target object, it was a tuple and containing both arrays. And when this object was converted to bytes array, array was created like a main array with 2 arrays inside, and this is how it was sent. And when we converted back to NumPy array, then it was not converted to be exactly the same object as it was originally. It was converted to NumPy array with 2 arrays inside, and then we do this extra step to convert it back to be exactly the same object, a tuple object to be the same like it was originally. Because otherwise, TensorFlow, we're using TensorFlow, and TensorFlow training model, the method which trains the model, the fit method, would not be able to recognize this target as the one which is suitable for training. So we do this little trick to return the state as it was originally. And as it is done, then we return all the sets back to the main method from where it was called, and then the rest, it kind of straightforward, because we build the model and compile it, and then we run standard TensorFlow fit API call, which trains the model, and we pass the data here. And this data, because it's we're using NumPy arrays, which we brought back from bytes array, then it works the same as like with original data set. It doesn't know that data actually traveled through gRPC from another service. It's transferred in this case. Okay, and just to show you that it actually works, yeah, I could run training service test. Then it makes a call to another application. Data was prepared over here. It was sent back, and then training loop runs, right? And training executed 100 iterations, and it reports back information about the quality of the training, right? So that's a standard thing as well. So we see that communication works. We are able to make a call from training service to data service. We were able to package the data, send it back from data service to training service, and training loop executed successfully. Right, and this is, of course, a simple example. In a real case, you would have probably logic for data processing would be way more complex, and you may have different checks and stuff running for data processing, and having this logic to be runnable in a separate service is good for maintenance, but not only. It's also good for runtime, because when you have data processing running in one service, training running in different service, you have more options for scalability. You could run this service for data processing on one machine, or on one container with certain resources, and training you could run on GPU, for example, to improve training performance and so on. Right. So this option, when you can split, it gives a lot of good possibilities, and it's running ML flow in microservices is quite it's kind of natural, because comparing to those ERP applications, when you have database in the background, with machine learning, typically you don't have a database, and it's easier to split logic into different services. You're not constrained by a database, so it makes it more natural. Okay, so that was my demo, and yeah, the main point was to show you that to explain how we applied gRPC in ML domain, and to explain specifics of ML and why we think gRPC is useful for ML use cases.